Hello, welcome. Today's webinar will be on why people dangerously ignore motor controllers in a SIF. So why is everyone here today? Well, this is actually like a second part. I had another webinar a few weeks ago talking about motor controllers, but we're really trying to bring to light this void in the industry. And today what we'll be doing is really talking about the failure rate data, where it's coming from, share some examples of how we've seen motor controllers used in SIFs, and then how you can achieve different SIL ratings depending on what the risk reduction factor is needed for that SIF. I am Ted Stewart. I'm the Program Development and Compliance Manager for exida. Quick background on myself. I started at Lockheed Martin as in missile and fire control. I then shifted over to Harris Corporation, where we made these little black boxes that could locate and track people. So it was a lot of fun. And then about 6-7 years ago, I transferred over here to exida from sunny Florida to Pennsylvania. It was a big life change for me, but I wouldn't have done any other way. It's been a phenomenal career for me. I'm now responsible for a lot of different programs. OEM functional safety and user functional safety, cybersecurity, automotive, machinery, robotics, and railway. So every day that we come to work, man, it's something new. It's exciting. We're always evolving and really trying to help people learn the industry. We are a global company. We have offices around the world. Every year, a little exida triangle pops up on this map, and one of our most recent locations was exida Israel. We are also most likely, we can't say where the location is, but hopefully by the end of this year, we may even have another triangle, which is really, really exciting. But yeah, we deal with functional safety, alarm management, cybersecurity, and because we're a customer-focused company, we really are the only company that encompasses that complete life cycle of functional safety and cybersecurity, which makes us unique. But the other unique part is that, and I think we could update this chart even more, is it's closer to about 97% employee ownership now, where we have over 100 global experts. We've done over 1,000 certification jobs and 500,000 SIFs model. That's a lot. But I think that's one reason for our success is the fact that everybody has a piece in this company. So the harder we work, the more we get out of it, because the more successful our company is, the more successful we are too. And two quick slides here on the software that we have. It does make everyone's life easier. Excellentia was developed, in my opinion, to do so. Gone are the days of using those simplified equations just because you didn't really want to do your Markov models or have user error. And actually in this presentation, I'll actually go through and use Silver, which is one of the modules in Excellentia, and kind of share some screenshots of me using that program. The really unique thing with Excellentia that I just want to get my point across is that no matter where you are in the life cycle, and or in your project, I should say, whether it's functional safety, alarms management, cybersecurity, there is now a module for every single piece of that life cycle. So it's really neat. So no matter where you are, there is a module that would help you out with that tool. So it's pretty unique. And it really was developed because of our customers. We always get feedback, and as we get all this feedback, we keep implementing their feedback into this product, making it more robust and more user-friendly, so to speak. We do research, and we do a lot of research, and truthfully, it is to everybody's benefit. We feel that, look, if we're an open book, we share all the knowledge and strength that we have. It really makes our marketplace more educated. It helps you teach you, your colleagues, and really the faster you and your colleagues learn, the more we can then go off and do other things to really step up the bar for the next safety initiative, to really improving our industry, to making us safer. So like today's webinar, we do these once a week. We're telling you as much as we know, everything we can. Why? Because we want to keep moving and advancing through this industry. And you can see, we pretty much we have a lot of the reference material out there, the webinars, the white papers, you name it, we do it. Even if people have a topic, hey, we'd like to learn a bit about this, can you do a webinar on it? We usually do. So if you have any ideas, make sure you contact us and share us with what you want us to talk about. In about 20 years time since we've been around, we've really taken over the industry, which is kind of fun. We've done the majority of this safety device certifications. We've just surpassed, and now we're the leader of the logic solver certification, which is a really cool trait. Everybody got the same start here with cybersecurity, so we really took off there. So we've been doing extremely well in cyber, which is fun. Yeah, a lot of stuff going on, huh? But anyways, so today's webinar, we're going to talk about the topics here of the classification of what a motor controller is. That way, you and I can kind of stay on the same page as to when I call a motor controller, we can all say, oh, okay, that's what Ted means, and we'll talk about why I feel motor controllers are being ignored in SIF designs, and then of course we'll go through some SIF examples with you. And then if you have any questions, I'll go ahead and get those answered as well. So what a motor controller is, well, if you go and you, let's just do the common thing, you go and you Google something, right? You have really broad definitions and you have really technical definitions. Well, I kind of picked two of them to show the extremities there and show that, look, it's not really a black and white word or topic. There's a lot of gray in it. And so you could find something that says, hey, it's a motor controller, it's a standalone device, and it powers a motor on and off, right? Or it could be something like the second paragraph there, where it's a motor controller, it has predetermined manners of performances for an electric motor. It could be manual, it could be automatic, starting, stopping, reverse, forward, rotation, regulating speeds, torque limits. And so you can see that it's very much involved as well. And we kind of more so on that second term, where we feel like a motor controller is a very smart device in a sense, and we actually classify motor controller, and there's also motor controller centers, right? So, but if you say motor controller, we think, look, it branches out where it could be a drive, it could be a starter, and then when we have things like relays and contactors, those are, we feel, are devices, and they attach to those drives and starters. And so that's how we kind of see things. And for those, hopefully, I think everybody's familiar with motor controllers, but like for a drive, it could be something, well, my example is actually, I do a lot with drives, where we talk about the variable frequency drives, the VFDs, and then we'll also talk about the safe torque off option and how that can actually improve safety as well. For starters, it could be things like direct online, which could have toggle or rotary controllers. We could have soft starters, even star delta or auto transformer starters. So there's a lot of different products out there within these two categories, but we do feel like relays and contactors, they kind of just attach to these motor controllers. And so that's kind of how I classify things. If you have a different way of classification, or you have a source of information that identifies everything, please let me know, because I'm not going to practice like I'm an expert in this realm, but I am trying to understand as much as I can, as fast as I can. So today, why would we have this influx of motor controller webinars and seminars that we've been giving? Well, because there's really is a need, and the Institute of Society of Automation, I just said that wrong, but ISA, they did a survey, and you can see here when people were asked, do you use electric final elements? Literally like 99% of people said yes, we do. And so it was kind of saying, okay, well, if everybody's using them, and then when you break it out and say, well, if it was based off of 80,000 SIF safety designs, and 16% of all safety designs, people said they use electric final element, well, of that 16%, how many of that 16% were like motor controllers, motor speed interrupts, motor starters? You can see here 92% of it. So what does that really mean? You break it down, and it kind of equates to saying that really 1 out of 6 or even 15% of all SIF designs of the 80,000, they use some type of motor controller or motor speed interrupt. My question is how? How are people using this if there's no real data there? And I'm going to kind of go into what I believe people are doing, right? So how are these engineers really designing these systems and selecting this device? Okay, a little humor, right? Because maybe they're looking the other way. Maybe they design out the motor controller because they don't really know how to use it. Maybe they're using prior use justification. Maybe they don't even have prior use justification, and maybe they could find some kind of certificate, but they don't even know what the certificate really was for. So there's a lot of different things that we're noticing when we're asking people, how are you using these? How are you designing your safety systems with these motor controllers? And we're constantly learning and getting research. And one of the things that survey had said was, okay, when you're selecting equipment for that safety instrument system, what criteria do you accept when you have to deal with 61511 for all the end users out there? And one of the things they say is, look, we look for the 61508 certificate, right? That's the main thing that this survey presented. The second main thing was a FMEDA report, which makes sense because that FMEDA is where your failure rates are, and that's what you need when you're developing these systems. Okay, so if you're looking for certificates, that kind of leads us into saying, okay, well, if you're looking at certificates, how do you know if the product can actually be used in your system? So the first thing you want to look at on that certificate is, well, does it talk about PFD or does it talk about PFH? And you need to think about, how is your product going to be used? Do you expect the frequency of demand for operation mode or the operation made on that safety-related system? Does it have to be, does that demand greater than a year, or is it no greater than a year, right? So if it's less than a year, if it's no greater than that 1 year, then it's going to be low demand. If you expect the frequency of demand for operation made on that safety-related system to be greater than once per year, then it's going to be high or continuous mode. So that's something very important to keep in mind. Now let's see what standard is it really certified to. When you see certified motor controller, whether it's a contactor, a relay, a motor starter, or whatever, you will often see these products advertised as certified. But, there's always this big but here. 99 out of 100 times I would say they are certified to the machine safety standards, which is okay. There's nothing wrong with that, but it's usually the IEC 62061 or 13849, ISO 13849. Now this doesn't, like I said, impede on that certificate by any means, but it should be a red flag for anyone needing to use this product in that low demand application, right? So if you need that PFD number, that should probably be a really big red flag, and that should not be a product you use in this system. Now, the next thing is, are there failure rates that are attached to the certificate, right? So you got the certificate, okay, yeah, the standard's confirmed, I see all that, and on the certificate, are there failure rates, or are you looking at and you're just seeing a PFD number, or maybe you're seeing a PFH number? Because remember that there's 9 different variables when you calculate the PFD or PFH. Things like mission time, proof test interval, proof test duration, site safety index, and many others. Now, how do you know you are using it correctly by simply just using that number without putting it in your safety parameters, right? So one other thing to look for, and I'll be done with this, just because it is important though, is you have low and then you have high failure rates, okay? And they're very different. And what matters is that you have different environmental factors that come into play, and the techniques used are also very different. So for example, low demand failure rates are normally calculated using this FMEDA approach, which is your failure mode effect diagnostic analysis. Then you have high demand failure rates are normally calculated by what? Yeah, by that B10 approach. What is B10? Essentially, B10 is this measurement. It's a measurement of time, let's just say that 10, right? So by 10% of a population of this product, it's saying that 10% of the population, it's got to fail. And when that 10% fails, you're going to start realizing what that B10 number is. And the term, it really originated from manufacturers of anti-friction bearings, and it's used to express the minimum lifetime of 90% of a given batch of bearings operating with this speed and load tolerances. And so that's kind of where it came from, and it's something that's always moving, right? It never stops. And so that's where this calculation came from. It's a great calculation for high demand continuous type of products. So what happens though is things like stiction, corrosion, cold welding, any kind of binding, they all play this huge part or factor in low demand situations. Quick example is, you have that coffee mug, you're drinking, you put it down, you leave for the day, you come back, what's happened? You pick up that coffee mug, kind of sticks a little bit. I know, simple example, but that's the same thing as like stiction, right? So if you have a valve and it's not being used for at least, not even once a year, when you want that thing to work, by golly, if you're not proof testing it or not moving it at all, it may not move, it might get stuck. And so that's what happens. That's why the failure rates are increased. And so if you're using high demand failure rates in a low demand application, it ends up being extremely optimistic, and it could lead to a lot of dangerous results. I may have been on a little soapbox there, but hey, it's fun to bring things to light. So now, like all equipment used in a SIF, a motor controller, it must also be justified based on the integrity. And the good news is that we do have websites here where when you want to use a certified device, if it's a motor controller, if it's a valve, if it's an actuator, it's all these other items, and you need something so related or capable, to whatever level you're trying to achieve. I'm talking to the end users. This is kind of like your shopping cart. It's your Amazon of nerd stuff, right? For manufacturers. So you can now come here and say, hey, I need a motor controller. What's certified? Let me look through here. There's links to those actual manufacturers to purchase these products. So anything that we've certified, we put here for you so that you can see. The good and bad news. Good news is, hey, there is one or two products there. The bad news is that's really it that's on there. There's a lot of products in our bandwidth right now that we're pushing through certification. We got a couple more inquiries a few weeks ago that they're now wanting to get their motor controller, their VFDs certified. So that's good news, thumbs up there. But what happens if, hey, I got a project going on right now and I need failure information? I touched on this like 2 weeks ago, my last webinar. But if you don't have information, the next step you need to go to is you need to go to the generic area, right? So use generic failure information, www.cellsafedata.com. On here, you'll see here, yes, it's a blurry picture. It's not your eyes. You'll see here that there's a lower and upper limit for your dangerous undetected failures. I tell people use the upper limit. You can probably, maybe if you know your device is good, motor controller is good, and maybe you don't have the prior use information, you can probably use the lower limit items. But in reality, you'll go through here. If you have a VFD drive, you have one set of numbers. If that VFD has a safe torque off option, hey, guess what? It actually improves the safety. And that's one thing we'll talk about. One of our examples is when you have a drive, but then you also have the safe torque off option, how it really helps your safety system, right? And that's what we'll talk about. So let's jump on in to the 4 different motor controller examples. The first one. All right, so this was actually a real, I say real life customer. It was a customer of ours, and I blurred out a lot of the sensitive information, and I left a few things in there that weren't sensitive information, obviously. So this one, you have a product. This was the sensor was a Krone sensor. They used a Mark 6 GE product logic solver, 2 out of 3. They also chose generic information. They had a relay, and they also had a motor starter in this system, which was great. They had the site safety index. They said they were an SSI 2, which is standard. Okay, that's actually usually where the majority of everybody is. And so when they did their calculation, they noticed, hey, we need to be a SIL 2, but we only achieved a SIL 1. So what can people do when they develop a system? And using the software is great because you don't have to redo the calculations. You kind of just click buttons and it does it all for you. So if you see in the middle of the screen, you see there that it says it's a SIL 1 was achieved. And if I go over here and I say, okay, well, as I change slides, so I'm going to change the slides here. I'm going to make a change here. What I'm going to change is I now changed out my Krone sensor to a Honeywell SMV sensor. Why? Well, but guess what? That sensor that I had before was not a certified sensor. So let me throw the Honeywell SMV 800 in there. That's already certified. That automatically gives you, well, not automatically, but it more than likely a certified product does have better failure rates. Because an FMEDA was performed on it, and it wasn't just generic information. So we added that. What did that do immediately? Well, if you look over here, this was on the last screen a SIL 1 for your architecture. It now reached a SIL 2 architecture for your sensors, which is what we really needed. The thing that it didn't change is it still didn't change our achieved SIL level. We still only reached a SIL 1. Why was that? Well, if you look there at the bottom middle of your screen, you can see the PFD average. It didn't change. It remained a SIL 1 because, as I spoke about in the last webinar, you have 3 barriers. You have the hardware, you have the systematic side, and you have the PFD. Okay, and the PFD, and all 3 must be the minimum for you to achieve it. So if you have one that's a SIL 1, something's a SIL 2, and a barrier that's a SIL 3, kind of like in this situation, you will only ever hit SIL 1. Until you fix it. So they discussed, okay, here's what we are. How do we achieve a SIL 2? What are some things we can do? Well, in their situation, what they ended up doing was they, hold on here, yeah. So what they ended up doing is they reduced their proof testing, right? So right now they're at 4 years. They reduced it down to 1 year, and by using the same equipment, Changing it to 1 year, guess what they achieved? That's how they got to their SIL2 PFD average. Everybody was happy. Hey, we got smiley faces, you know, the whole works here. Kabang. So that's what happened in this motor controller situation. We didn't have to change the design. We just simply changed proof testing by using generic information. So they did not use any kind of certified equipment. The products could have been certified. They're probably good enough to be certified products. We don't know because that FMETA wasn't done, no certification was done on those. So we had to use generic information because you have to do your due diligence because we're dealing with safety here. All right, so now let's skip over to the next example. The next example, so what I wanted to do is I actually added in these slides. All right, perfect. All right, so now example number 2. Oh, come on. Great. Example number 2, what we did here is, now this is not a real scenario. These are examples that we built because from feedback from our last webinar, they had different setups and like, hey, I wonder if this could work. Could this work? What SIL would you achieve if you did it? So we created 3 additional examples now, 1 real world, and then these are the 3. What we're going to do is we're going to build on this design and show how you can improve a design even using that generic field failure information. So with this one, you have a high pressure shutdown pump. Okay, you got your control system. The analog output of that control system is your speed, of course, and then your system that you have in place with your pressure transmitters. We chose an Emerson Delta V with a discrete output is to what? You need to shut down that speed. So what happens is it gets triggered. We have a relay in place, and that relay, when we de-energize that relay, it opens like you see in the picture there, and that VFD input goes to 0, which then what? It then turns the motor off, essentially, right? And that's all good. Now, when we build that system, as you can see here, the SIL PFD, we had a SIL2. Your architecture for your sensor was a SIL2. Logic solver was a SIL3. Your final element was a SIL1. What is your final element? Yes, that relay, that VFD, the motor contactor. So that, because of that generic information, it kept this system from acquiring a SIL2 system. And let's say, hey, our objective is we need a SIL3 capable system using these motor controllers. Okay, and so that's something we need to look at now. So now what we'll do is let's change this design slightly. Okay. And there's my SIL1, by the way. That's what kept us from. Now let's change it. Now I'm going to go back and forth with the slides so you can see what we did differently. What we're doing now is we're taking out the VFD, but we're adding a new VFD that has safe torque off input. All right. It can now shut down independently, right? Because now it's just one device. Whereas before, if I go back to the slide, we used a relay to shut down the VFD. All right. So now we're going to have a device that's smarter. It can shut itself down independently. What does that do is, as I showed you back, and actually if I went back to that other slide, what you'll notice is that a VFD with a safe torque off, actually anyone can do this. If you go to silsafedata.com, you'll notice that a VFD with STO has such lower failure rates because it's independently can shut down this motor. It's much better for your system. Because of this, what you'll see is that now final element changed to a SIL2 system. It allowed the whole SIF to become a SIL2, which is fantastic. Okay, we're like, yeah, that's great, but now what else do you have to do so that we can achieve a SIL3? Well, a lot of ways with a motor controller that you're going to have to do is you're going to have to involve architecture redundancy, right? And so that's what we did here. All right, so the next system we built, we used 3 pressure transmitters, or three pressure transmitters. We had that 2 out of 3 there with the Delta V system. We had the discrete output. Was the speed shutdown once again. But what's unique about this is we left the safe torque off VFD, but we added an independent contactor. So now you have a 1 out of 2 there where you have 2 different independent ways that you can turn this motor off, and one does not rely on the other. So if the VFD cuts off, it cuts power to the motor. If the contactor opens and de-energizes, guess what? That cuts the motor off, right? So now you have these 2 independent ways. You have that redundancy, and because you have that redundancy, you now what? Everything, smiley face again, everything achieves your SIL3. That's how you design systems to SIL 3 capability. We have manufacturers that are saying, hey, look, everything we see is only SIL 2, SIL 2, SIL 1. It's even worth us trying to create a product for SIL 3 capability. The answer is yes, right? So you can have it SIL 2 HFT 0, SIL 3 HFT 1, and be good to go. So those are the examples. That was the summary for today's webinar. It's really important that, a lot of these SIFs that are being developed, people do seriously just ignore it. They act like it's not there. They design around it. They use high demand information because they figure, hey, if I use anything, at least I'm using something, right? And so now what we're telling people, look, yes, that was the old way of doing things. Now at least use your generic failure information until that manufacturer certifies their equipment so that you can now use it. And we're gathering information like crazy. Any help from anyone out there would be greatly appreciated. If you know manufacturers or if you are a manufacturer, let us know and we'll try and help you out so that we can get this industry moving a little bit quicker than it is. So that's another reason why people are looking for these types of certifications. A couple quick slides and then I'll get to those questions. So thanks everyone. Wow, this was a really great turnout. But we do have classes. You can see here whether it's fire and gas. For your end user, 61511, we have 61508 training, functional safety training, automotive training. Everything now is becoming online, which is kind of cool. That's really neat to see. We're even developing other courses. Oh wow, CS201 is going online. That's really cool. I'm even learning about things. If you want to come see us, these are the last 4 shows of the year that we'll be at. We'll be in Germany end of September. We'll also be at Emerson Exchange end of September. And then we have 2 shows in November with ISA, PIC, and then the Rockwell Automation Fair. And those are our shows. If you got questions, let us know. Follow us, like us. Hey, everybody, thank you so much for joining me. Like I said, you're on this webinar. We're going to get you those slides. This will be a recorded webinar, and I will get every single question that was asked to me. I'll write an answer, and I'll send you a PDF so that you can have them all. And if more things come up, let me know. I'd love to help you out. We're kind of in this together, all right? Hey, thanks again. Take care. Bye-bye for now.